Graphing linear functions, specifically looking at like the intercepts in this section. So we have three objectives. Number one, graphing linear functions. Number two, graphing linear functions by using intercepts. And number three, graphing vertical and horizontal lines. So for objective one, graphing linear functions, we're going to start here with example one. We're going to graph two different equations here. We want to graph f of x equals 2x. And then when we're done with that one, we're going to graph g of x equals 2x plus 3. Notice the nice use of function notation here. This is going to keep us nice and organized by knowing that there are two different equations that we're going to graph. So let's start with f of x. One of the easiest ways to graph something is to use a t-chart. You can pick any numbers that you would like for x because it's our independent variable. You can plug it in and get that dependent or our y value out of the equation. So if we plug in 0 for x, we get that y is 0. When you plug in x as 1, you get that our y is 2. And when you plug in that our x is 2, we find that our y is 4. 3 ordered pairs gives us something that we can graph and double check our work. So 0, 0 is our origin, 1, 2, and 2, 4. Notice all three of our dots are nicely lined up. That means we are doing good. We can connect them, add arrow points on the end. Now let's do this one more time. We'll do this with our g function. We're going to use the same little t-chart, and let's use the same x values, 0, 1, and 2. So we're going to plug in 0 where the x goes in our equation. 2 times 0 is 0, plus 3 gives us y equals 3. 2 times 1 gives us 2, plus 3 gives us 5. And when we plug in 2 for our x, we multiply first, so we get 4 plus 3, and we get y equals 7. That gives us 3 points to graph. 0, 3, 1, 5, 2, 7, right there. 3 points perfectly in a row. We can connect them up. Add those arrow points on the end. Now, before I move past this one, I just wanted to point out the fact that most of this equation was the same. The only thing that was different between these two was this number on the end, this plus 3, where the other equation didn't have it. And because this section is going to focus on our intercepts, I just wanted to point out that that plus 3 is where we are crossing our y-axis. And for our f of x function, there was no plus or minus a number without a variable. And so that would be like having a plus 0. So that was then the y-intercept for that equation. So let's look a little bit more at these intercepts. Objective 2, we're going to graph linear functions by using our intercepts instead of using a t-chart. So just to define what we know here, our x-intercepts are when we are crossing our x-axis, so any point along this line. And then our y-intercepts are when we are crossing our y-axis along this line. Now, what you'll notice from these is they tend to have the same formatting. So an x-intercept is going to be always in the form of your x, 0. That's where you're going to cross your x-axis. Where you cross the x-axis. And our y-intercepts are always going to be in the form of 0, the y, because that is where you cross the y-axis. So we are going to look for these two specific ordered pairs, and then we can graph with them. Example 2. Find the y-intercept of the graph of each equation. Write it as an ordered pair. Now, because we are looking specifically for the y-intercept in these problems, that y-intercept is always going to be in that form of 0, y. So we just need to identify from A and B, these two different equations, then what is the y-intercept? And if you remember from previous math courses, we're kind of slowly building up to it. But this idea of y equals mx plus b, we haven't defined what all of these parts are for you yet. But anytime your equation is in the form f of x equals or y equals, it's that number piece by itself, the one not connected to the variable x. It's typically the last thing you see, but it could be reordered for you. And it's that number piece by itself. So notice on part A, it's this plus 5.3. And for B, it's this minus 1/4. If you go back to that first example, notice between the two equations, it's that plus 3 that changed where that entire line crossed our y-axis. So these are our y-intercepts. And when you have solved the equation for y equals, you can see that in your equation. There is no math that needs to be done to find it. The only thing we need to do here is just write it as an ordered pair. So 0, 5.3 and 0, negative 1/4. Now, if you don't have your equation in that y equals mx plus b, we're going to need to do a little math to find it. And we're going to have to do some math to find our x-intercept as well. So we're going to define how we find these things right here. So no matter what format your equation looks like, if you want to find the x-intercept, you will plug 0 in for the y. You plug y equals 0, and then that means you will then solve the equation for x equals. And that's your x-intercept. Same goes true for the y-intercept. If you want the y-intercept, you are going to plug x equals 0 in for the x, and then you are going to solve for the y. And then just to remind you, x-intercepts are going to be in that form x, 0. Y-intercepts are in the form 0, that y. So let's try that here with example 3. We have 4 plus y equals 2/3 x. It's not in a format that we probably have typically seen. We can rearrange it, but we don't have to. So we're going to start by finding your x-intercept, which means we're going to plug in 0 where the y is. So if we plug in 0 where the y goes, we have 4 equals 2/3 x. And then just to remind us, when we're dealing with fractions, you can multiply everything by the denominator, or if you have more than one denominator, by your least common denominator. And that's going to help you clear out the fraction. So multiplying in by 3 is going to get rid of that 3 on the bottom. We have 2x on the right. And on the other side, 4 times 3 gives us 12. Divide both sides by 2. We get x equals 6. So that is going to be 6, 0 as an ordered pair. And I can go ahead and graph that. 1, 2, 3, 4, 5, 6. There we go. That's our x-intercept. That's where our line is going to cross our x-axis. And then we're going to do the same thing for our y-intercept. But this time we're going to plug in 0 where the x is. So 4 plus y equals 2/3 times 0. 0 times anything is going to cancel. So we have 4 plus y equals 0. I just need to get y by itself, so I'm going to subtract 4 from both sides. Y equals -4. So that's in the form 0, -4. We can graph it, and then we can connect our dots, extend on in both directions. Make sure you put the arrow points on the end. That would be graphing with the x and y intercepts. And be careful. If we just ask you to graph, you can graph with any method you have. But if it asks you to graph with your intercepts, you must use those 2 points on the graph. Let's try this one more time. Example 4. We want to graph y equals 3x by finding and plotting our intercepts. So let's start with our x-intercept. I'm plugging in 0 where the y is. I do want to solve for x, so I'm going to divide both sides by 3. And I get x is 0. So that is the ordered pair, 0, 0. And I make my dot on my graph. So that is where our line is crossing our x-axis. For our y-axis, we're going to do the same process. This time we're going to plug in the 0 where the x goes. 3 times 0 gives us 0. And we get y equals 0. So that is the ordered pair, 0, 0. And I'm going to put that dot right there so you can kind of see both. And you'll notice really quickly that that did not give us much to graph with. If you ever solve for x or y intercept and you get the origin, remember these are called your origin, 0, 0. That means that that happens to be the only spot where it both crosses the x and the y-intercept at the same moment. But that didn't help me get a line. So now that we see that it's only giving us 1 point, we need to find another point. So that's when we resort back to our little t-chart and pick in any number that you want for x so we can get something to graph. So I'm going to plug in a 1. 3 times 1 in our equation gives us a y equals 3. That gives me at least that secondary point to graph. So if they ask you for intercepts and you only get the origin, you will have to find another point. T-chart is the way to go. You can even find a third point just to double check that they are all going to line up together. Objective 3, graphing vertical and horizontal lines. These are our 2 special cases here because horizontal and vertical lines, because they go straight up and down or straight left and right, they're only going to cross one of the axes and not both. So just a quick recap, vertical lines are those up and downs. So if you imagine that on a graph real quick, and it's going up and down, think about what axis it is cutting through. So it is going to touch that x-axis and keep on going. It cuts through our x-axis. So vertical lines are all being defined by x equals where they are crossing. That is the entire equation for a vertical line, is x equals one number, where it crosses. Same is true for horizontal. So if you think about horizontal lines, they are left to right. Think about putting them on the graph. Think about what axis it is cutting through. So it cuts through your y-axis and keeps on going. So these are always going to be defined by y equals a number. It is the point that it is cutting through and it keeps on going. There is no slope to either of these equations because we are not going uphill or downhill. These are flat or straight up and down. So let's try to graph them. Example 5, we have graph x equals -3. Because it is just an x variable in here, we can get this on our graph And this is in the format that lets us know that this is a vertical line. Vertical lines are always x equals a number. So all you needed was that -3, and then you can just make that line straight up, straight down. And if you're ever asked for a second or a third point, you could pick anything along that line. But notice they all have that same x value. It would just be a different y that goes with it. Example 6, y equals 4. Again, there's only one variable in here, so that's our clue that it's one of our special cases. And because it's our y, it's a horizontal line. So go to where y equals 4, and then extend that line out left and right, horizontal. And if you need any secondary or third points, you can pick anything along that line. So it would have the same y value, just a different x.